Hello, this is Miss Goodwin, and today we are continuing to cover Objective 5.1, Circle Properties and Theorems. So the objective is that we can identify and describe the relationships among inscribed angles, radii, and chords in a circle. So we are still continuing the same thing. In the previous video, we looked at the central angle theorem and used that to find angle measures and arc measures. In this one, we are going to be covering a few different theorems to find other angles and then finding the lengths of segments inside of a circle along with arc length and sector area. So to get started, we are going to look at the cyclic quadrilateral theorem. This is something you're just going to have to kind of remember, but it basically says that opposite angles in a quadrilateral, which is a four-sided shape, that is inscribed in a circle, meaning all of its points fall on the edge of the circle, add up to 180 degrees. So, for example, we have angles B and D. Add those together, those give you 180. Angles A and C. Those add up to give you 180 as well. I'll just do a quick example real quick so I can show you how to do this. We know that these angles BD equal 180, D equals 100, so we got B plus 100 equals 180. Subtract 100 from both sides. We have B equals 80 degrees. And then same with A and C. A plus C equals 180. A is 50, so we got 50 plus C equals 180. Minus 50 minus 50. C equals 130. And that's it for the cyclic quadrilateral theorem. Now let's look at the intersecting chords theorem. This is a fun one. So we have our circle here, and notice that they do not line, the chords in the circle do not line up in the middle. So we have two chords. They have this funny little relationship, whoopsies, just gonna leave that there, where if we multiply the two parts of the chord, so in this case A times C, that is equal to the other parts of the other split chord being multiplied together. So this split chord, the product of both segments of that chord equals the product of the segment of the other chord. So AC equals BD. So let's just look at an example of that. So another way you might see it is AY, CY, basically with two letters. That is just referring to the endpoints of that segment. So here we have AY, that measurement is 6. BY, that measurement is 4. CY, that measurement is 2. And we need to find DY. So we're going to take both parts of this chord, multiplying together, we got 6 times 2. And set that equal to the other segments being multiplied together. So we got 4 times segment DY. 6 times 2 equals 12. And then we have 4 times DY. Divide both sides by 4 to get dy alone. And we can see 3 equals dy. And that's that. Multiply both parts of the chord. Set it equal to the product of the other chord. And then solve for your variable. Let's look at another one. I'm going to... Never mind. Let's just do what we've been doing. AY, we do not have that. Actually, let me give you a chance to do this one by yourself. So go ahead, do this one real quick. Pause the video if you need to. And now I'm going to do it. So BY right here, that is 5. CY here is 6. And DY here is 3. So to make this easier, I'm just going to write it using the first letters. So A times C equals B times D. A is our variables. C is 6. B is 5. D is 3. We have A times 6 equals 15. Divide both sides by 6. We have A equals 15, 6, which is equal to 5 halves. So segment AY is 5 halves. And that is how we find our segment in our chords of our circle. Now we are going to look at sector area and arc length. This is another fun one. So you might be familiar with circumference and area. Circumference is the outside of the circle. The distance around the outside of the circle. And the formula for that is 2 pi r, where r is the radius. Now area, that is everything on the inside of the circle, how much space that circle takes up. And that is equal to pi r squared. So those are both for the entire circle. But what if we don't want the entire circle? What if we don't want the entire pizza? Well, in this case, you're going to need to know not just the radius, but the angle measure as well. So this symbol here is what we call theta. It's just another variable. Just like we use X, Y, Z. This is a Greek symbol that we use for angles. So knowing those two can help you figure out the arc length and sector area. Arc length is this right here. It's just the crust of the pizza. Slice. And its formula looks very similar. It's going to be 2 pi r. But we are also going to multiply that by the fraction of theta over 360. Theta being whatever the angle is. So we're taking a fraction of that pizza. This may also be simplified because it's a 2 and 30 to just pi r theta over 180. Both of these are correct. We just simplified the 2 and 360. Now sector area, similar deal. Sector area is just how much of that pizza we have. How much pizza is in our slice total. And it's going to have pi r squared. And then we are going to still multiply that by theta over 360. And these are our new formulas here. Alright, so I've just rewritten the formulas here for sector area and arc length. Now we're going to look at an example. So we want to find the arc length and the sector area. So as we can see here, we have our r, so r equals 3. And we have our angle, which is 120 degrees. So let's do our first one, arc length, which is this right here. Arc length is the pi r theta over 180, or 2 pi r theta over 360. So I'm going to plug in our variables. We have pi times 3 times 120 over 180. 3 times 120 gives us 360. So we have pi times 360 over 180. 360 and 180 cancel out to 2 over 1. So we are just left with 2 pi. Now if you want to simplify that further, pi is about 3.14. So 2 pi would be about 6.28. And that is our arc length. Now let's look for our sector area. So sector area is going to be pi r squared times theta over 360. So I plug in my variables. We got pi times 3 squared times 120 over 180. This one's going to be a little nasty. That gives us pi times 9 times 120 over 180. This could be simplified to 2 over 3. Which means this could be simplified to just 3 over 1. Oh, and that worked out to be 3 pi. I lied. That would be 6 pi, because 3 times 2. So we get pi times 3 times 2, which is 6 pi. And honestly, we can just leave it like that for now. So our sector area is 6 pi. So we have our arc length and our sector area, and we are done. Now go ahead, try this problem on your own. Pause the video if you have to. And now I'm going to get started. So we have our radius is 5 and our theta is 90 degrees. So let's take a look. So arc length, which is pi r theta over 180. You get pi times 5 times 90 over 180. 90 and 180 cancel out, leaving us with just 2 on the bottom. So we get 5/2, or pi, times 5/2. And I'm going to just rewrite that to be 5/2 pi. And we are done. You don't have to simplify it any further than this. Okay. And last but not least, our arc length. So arc length is the space inside. I said arc length, I meant sector area. So we get pi times 5 squared times 90 over 360. This cancels out to give us a 4 on the bottom, and 5 squared is 25. So we have pi times 25 over 4. Let's rewrite that to be 25/4 pi. And I'm going to call it that. We don't have to simplify it further. Pi is just a number, but it's an irrational number. We could just put pi there and we know what we're talking about. And we are done. That is it for sector length and arc. Sector area and arc length. Yeah. So go ahead, summarize your notes, and then when you're done, go ahead, work on some of the practice. And I'll see you next time. Have a great day. Bye.